The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Welcome to Science for the People. Today, Desiree Schell will be exploring what it means to be a genius, what makes one, and how we measure it. On today's show, Desiree Schell will be talking with Scott Barry Kaufman, adjunct professor of psychology at New York University, about IQ testing and the challenges around it. Later on, she'll also chat with two organizers of the upcoming Skeptech conference in Minneapolis. But first, since we're talking about genius, Desiree sits down with Fritjof Capra and discusses one of history's most well-known geniuses, Leonardo da Vinci.
Hello and welcome to Science for the People. I'm Desiree Schell, and today I'm speaking to Fritjof Capra, PhD, physicist and systems theorist, and a founding director of the Center for Ecoliteracy in Berkeley. He's the author of several international bestsellers, including The Tao of Physics, The Web of Life, The Science of Leonardo, and he's co-author of the multidisciplinary textbook, The Systems View of Life, A Unifying Vision. And he's here to talk about his newest book today, Learning from Leonardo. Welcome to the show, sir.
Thank you very much for having me.
Now, this is not your first book about Leonardo da Vinci. So what was the focus in your first book?
Well, I have been fascinated by the genius of Leonardo da Vinci for many decades, and I spent the last 10 years studying his scientific writings in his famous notebooks, in facsimile editions of the notebooks, and I wrote two books about him. The first, The Science of Leonardo, is a general introduction to Leonardo the man, the Renaissance, science in the Renaissance, his scientific method, and his unique synthesis of art and science. And in the second book, Learning from Leonardo, I go into depth. I present an in-depth discussion of the main branches of Leonardo's scientific work, all the way from fluid dynamics and geology to botany, mechanics, the science of flight, and anatomy. It's an incredibly broad field, and most of his astonishing discoveries and achievements in these fields are virtually unknown to the general public. So I'm very excited about this book. I made a number of discoveries, which I think are contributions to the history of science.
And definitely the book was very science-focused, but it also seemed fairly personal. You seem to really want to get inside his head. Is that a fair statement?
Yeah, I think so. And, I got fascinated by Leonardo, and at the same time, this book is sort of an exorcism of Leonardo. I could write another 2 or 3 books. There's so much to be done, but I think I'm done with him now and turn my attention to other things. But I was definitely spellbound.
So what's the particular attraction for you then?
Well, the particular attraction is, first of all, the surprising fact that although there are hundreds of books about Leonardo da Vinci, there are very, very few books about his science. And even in those books, most of the historians get it wrong because they try to look at his science through Newtonian lenses, which is understandable because he lived 100 years before Galileo, and he developed single-handedly what we now call the scientific method. But he used this method to produce a science that is very different from that of Galileo and Newton. It's a science of living forms. It's a science of patterns, a science of transformations. And that fascinated me because that's how we do science today in the 21st century in our systems and complexity theories.
And that's one of the themes that you keep returning to in the book, that the key to Da Vinci's genius is his systemic way of thinking. Could you explain that a bit?
For him, solving a problem always meant finding out how it is connected to other problems or to other natural phenomena through a similarity of patterns. And that's what systemic thinking is, thinking in terms of relationships, in terms of patterns, in terms of processes. So throughout the notebooks, I came across passages that talk about patterns of relationships, that talk about transformations, that saw, a certain plant or animal or geological form just as a stage in an ongoing transformation. And that is why he sounds so modern to us, although he also has, Aristotelian roots and, lived in the Renaissance. But still a very modern approach to understanding life.
Well, you included a chart comparing when Da Vinci discovered certain natural concepts and laws and then the next time that they were discovered. And in some cases, that gap was hundreds of years. So
yeah, that's absolutely amazing. In most cases, it's 100 or 200.
Right.
And the most extreme example is one discovery in the anatomy of the heart, which was verified in the mid-20th century. So he was just incredibly ahead of his time.
Well, can that all be attributed to systemic thinking? Because how was he able to diverge so dramatically from what was understood at the time?
Well, first of all, he had a really remarkable gift of observation. He must have had an unnaturally sharp eye. He could, for instance, observe vortices of water or a complex flight path of a bird and draw it shortly after observing it with almost complete accuracy, something that was achieved only hundreds of years later with modern photography, with serial photography. So he had this gift of observation. It is part of the systemic thinking. Let me give you a very simple example. In the Renaissance and also later, it was very important for engineers, especially military engineers, to understand the flight path of a projectile, like, a cannonball or just a stone thrown in the air. And at Leonardo's time, and even 100 years later, there were several scientists, several physicists, who would draw this trajectory, and they would draw a straight line in some angle, then they would draw a little circle, and then they had the projectile fall down in vertically. And even Galileo in his early work did such a drawing. Now, Leonardo drew the exact parabola, which is without naming it, but he drew parabolic trajectories. How did he do it? Well, he couldn't observe the trajectory exactly. That's very difficult. But he argued that if you take a jet of water, then the water particles are like little bullets, and so the entire jet follows the same trajectory. And of course, as you can do yourself with a water hose, it's very easy to create a parabola with a jet of water. Galileo didn't think about that. Torricelli didn't think about it. The great scientists of the 16th century, none thought about it. Leonardo did.
Well, and we probably should be clear. Some of the ideas he came up with weren't exactly fleshed out, let's say, and he was sort of close on a number of concepts, but not
yes.
quite there, right?
Yes, there were many things. The most famous may be the circulation of blood, which was discovered 100 years later by William Harvey. And Leonardo almost got there, but not quite. And also in his drawings of turbulent flows of water, he got many things right, but other things wrong. But all in all, it's astonishing how much he achieved.
Well, that's the thing that I think is so interesting and remarkable, really, about Da Vinci is even when he was wrong, he was usually far less wrong than the other natural philosophers of that time.
Let me just give you a few examples, and readers can follow this in the timeline. As you said, I have it at the beginning of the book. So in what we now call fluid dynamics, the science of flow, he realized that the basic principles of flow hold for all substances, whether you talk about flowing water, flowing air, even flowing grains of rice with which he experimented. So that's why we can consider him the founder of fluid dynamics. In geology, he was the first to realize that the forms of the earth have been shaped over extremely long periods of time, what we now call geological time. That was rediscovered about 300 years later in geology. He was also the first to recognize and explain the origin of rock strata and their folding. In botany, he was interested in branching patterns of plants, and he related a branching pattern pattern to the flow of nutrients. So in modern language, we would say he related the form of the plant, which is called morphology in botany, to the physiology of the flow of nutrients. In mechanics, he just had a number of discoveries. The relativity of motion, he intuited the conservation of energy, the ballistic trajectories that I just mentioned. In aerodynamics, he discovered the principle of the wind tunnel, namely that a stationary body in flowing air is the same phenomenon as a moving body in still air. And so it just goes on and on.
You're making me feel very lazy, sir.
Yeah.
You're listening to Science for the People. I'm joined by Fritjof Capra, the author of Learning from Leonardo. Okay, so you've mentioned some specifics. Let's go back to water. Now, that was one of his enduring interests, correct?
Yes. Let me tell you first that my main discovery really is that at all levels of his research and also his art, the central focus of Leonardo was always his quest to understand the nature of life. And all the branches of his science and his art were in service of the central quest. Now, this has not been recognized before because until recently, when you think about the nature of biological life, this was always explained by biologists in terms of cells, of molecules, of DNA, and so on. But Leonardo, of course, who lived 200 years before the discovery of the microscope, didn't have access to that level of explanation. But now there is a systemic view of life, and this is what my textbook is about, the systems view of life, emerging from science. And there we see the nature of life in terms of metabolic processes and their patterns of organization. And this was what Leonardo was after in all of his research. So first of all, speaking of water, he recognized correctly that water is the main carrier and matrix of life. All living bodies exist in a watery environment. Every cell exists in a watery environment, and we need water, blood in the case of the human body and sap in the case of plants. We need water. The living organisms need water to transport nutrients to their tissues. And Leonardo also recognized that water sustains a living body. If water were not there, the body would completely collapse. So he recognized water as the vital fluid and matrix of life. I believe that his fascination with water had to do with that somehow he hoped to discover the secret of life or come closer to the secret of life by studying water. Another reason was that he was very fascinated by turbulent flows, by eddies, vortices, and they have a very interesting characteristic. If you just think of a whirlpool in your bathtub, it is a very characteristic form, a funnel and this kind of opening, and it remains stable although water flows through it all the time. So there's a coexistence of stability and change, and that is true for all living organisms. A water vortex is not alive, but it has this very basic characteristic of the coexistence of stability and flow, and I think Leonardo was fascinated by that.
Now, how exactly did he figure this out? Because I know he did a lot of observation, but he also did experiments.
Yes, he did experiments with water tanks. In the notebooks, he describes it exactly. He said you should have a glass tank and you should paint the back black so that you can see what happens. You should put sand at the bottom so you can see the effect of the turbulence at the bottom. And he invented various techniques of flow visualization that are still used in our laboratories today. For example, he would throw millet grains into the water so that he could see the flow lines. He would, when there were two streams merging, he would put dye into one of them so as to see how they would merge. And these are techniques that are still used today.
Now, what's the approximate time between when he made those discoveries and when someone else did?
He worked in the 15th century and in the early 16th century, and the fluid dynamics was really developed in the 19th century. And so there was, Osborne Reynolds was a key figure, various other physicists. It took until the 19th century.
Now, there is a chance that other people did make the same discoveries, but they perhaps weren't amazing artists and couldn't necessarily translate their ideas the same way that Da Vinci could, right?
Of course, but we know, for example, that hydraulic engineering was very important in Milan, where he spent most of his life. Lombardy was and is a very fertile agricultural region, and irrigation, canalization, the handling of floods from the rivers coming down from the Alps, and all that was very important. So hydraulic engineering was very highly developed in northern Italy. But Leonardo was the only hydraulic engineer who asked, how can I represent the flow of water theoretically? And what can I derive from this representation in terms of the basic principles of flow? Viscosity, for instance, the friction, the inner friction of water. He studied very carefully and understood it completely. Nobody else in his time did.
Well, it's odd that there don't seem to be the same kind of parallel discoveries with Leonardo that we see in other scientific fields. Because I've always thought that was fascinating, that when a concept or a technology is invented, when you look back, there are often multiple people in multiple countries that were working on it at the same time, but that doesn't seem to be the case here.
Well, because science itself was not developed to that extent. We must remember that he lived at the end of the Middle Ages and at the beginning, between the Middle Ages and the beginning of the modern era. That's when the Renaissance happened. And so you could also say the only way in which he was not a modern scientist was that he did not publish his work during his lifetime, and he did not engage in discussions with others. He must have done it verbally because he knew a lot of engineers and he knew the leading intellectuals of his time. But there's no exchange of letters. And I think this is what stimulated scientists 100 and 200 years later to work in different fields, but exchange letters and sometimes challenge each other with problems. And Leonardo was alone. And so that did not exist at his time.
Now, you spoke earlier about the fact that due to Da Vinci's systemic thinking, he was able to take observations from one area and then apply them to understanding another disparate area. So where else did he use his understanding of fluid dynamics?
He treated water as the carrier of life, and he looked at nature, he looked at landscapes and saw the flows of water through the landscapes that nourish the plants that grow there, and he compared this to the flow of human blood nourishing the tissues in our body. He also compared it to the flow of sap in trees. I'll give you one example which is quite intriguing. He argued that when you look at a tree, and you have the stem and then the trunk and then various branches and then finer branches. And he said, if you draw a circle or rather a sphere at any level of growth, and then you add up the cross sections of all the branches that go through this surface, then it will be more or less the same than the cross section of the trunk. And he argued that the thickness of a branch depends on the amount of sap that is transported to that branch, because the nutrients flow in the sap. And he realized that as the tree grows upwards and splits into branches, the flowing sap also divides. And he compared this to a river delta. And he had studied rivers, and he had studied the conservation of mass in the flow of water. And so it was easy for him to argue that the conservation of sap is the same. And then he, deduced the thickness of the branches from that. So that is sort of systemic thinking par excellence.
Well, how about air? How did he study that?
He studied it the same way he studied water. First of all, and that's another thing that I haven't mentioned yet, which makes him very modern. When he studies the flow of bird, the flight of bird, and he studies the air around the wing of a bird, that is basic aerodynamics, He says, I cannot see the air around the wings of a bird, but I know that the flow is the same as the flow of water with a similar obstacle. And so he makes experiments with the flow of water and then deduces the shape of the flow of air. And he realizes also that there are some differences, that mainly that air can be compressed and water can practically not be compressed. But he says, I will study water, and then he writes, and I will take the result as a ladder, and we would today say as a model, as a theoretical model to understand the flow of air. And then to visualize the flow of air, he would throw pieces of straw into the wind, for instance, and he would look at the pathways of clouds. He says the clouds swim on the air as objects swim in water. So it was always fluid dynamics, the flow of air and the flow of water compared.
Well, and you mentioned his observation of birds as well.
Yes, and that was another great passion in his life, because he wanted to fly like a bird, like so many people have before him. But he undertook this in a really rigorous, systematic way, studying not only aerodynamics, but also human anatomy, anatomy of birds, especially the muscles and the wings, and in addition to mechanical engineering. And he designed several flying machines that could have worked were it not for the weight of the materials he had available. So with the wood and heavy straps and so on, the flying machine was just too heavy to take off with muscular power, and eventually he realized that.
Well, he stuck with the flapping motion for a long time, right?
Yes. When he realized that this won't work, he made an estimate. He measured muscle power. He measured the muscular structure of the wings of birds. And then he said, we will not be able to do flapping flight, but gliding flight we may be able to do, because that requires much less force. By that time, he was too old to go back, over all his notes. And this is something also we see very often in Leonardo. When he makes mistakes, he was often too busy to go back and correct them, because he was always on to new things. So, but he would make a note somewhere and say, now I have recognized this is the fact, and that was wrong before. But he didn't, modify all his work, because, as I always wanted to write, but didn't. He also painted the Mona Lisa, so he was a busy man.
So how near is Leonardo's engineering of his drawings, his hang gliders, to our modern day hang gliders?
Well, they have actually built models and have flown with them. It's that near. In England, maybe 10 years ago, some engineers built one of his hang gliders with aluminum and light plastics and so on, and it worked perfectly well. So it's very close.
I feel like we should point out his anatomy illustrations, just in case we don't get to it, because they are amazing.
Yes, it's a treasure trove. There was an anatomist, Vesalius, a Belgian anatomist who lived 100 years after Leonardo, who is usually credited with being the father of modern anatomy. But Leonardo was far superior to Vesalius 100 years earlier. Now, this is something which is relatively well known, because there are several excellent books about Leonardo's anatomical drawings, but they really are stunning.
What would those drawings have done for the study of medicine at that time?
They would have shown people for the first time how the organs in the body are situated. In the book, if you remember, I have two drawings that are contemporary with Leonardo. One is a drawing of a pregnant woman where the womb is pictured as a circle, a hole, and then there's a sort of a little stick figure man inside as the baby, as the fetus. And compare that to Leonardo's drawing of the fetus, which is absolutely correct, including the fetal position, the nourishment through the umbilical cord, the membranes of the womb, all of that he drew with complete accuracy.
How different were those drawings than what was available?
They were totally different because the drawings of anatomy, except for the muscle anatomy, the superficial anatomy, many painters in the Renaissance studied anatomy to portray muscular bodies. But the inner organs were practically unknown. Their shape and relative position was practically unknown. So the representations were mostly symbolic. They also used astrology in medicine, and the whole anatomy and internal medicine was of a symbolic character. And with Leonardo, it really would have become real.
And you did include examples, and I do have to say that they look
yeah.
like they were drawn by children. The ones who...
I actually go through all of his anatomy, beginning with bones, then muscles, then nerves, tissues, and so on. And also one feature which is very important is that when he draws bones and muscles, he draws them within the body of as a whole, or within the limb as a whole. He always places the parts of the body within the anatomical context of the whole. Whereas if you look at the drawings of this Vesalius, he would take out bones and put them on a shelf and then draw them like this, instead of the way they are situated in the body.
Since we're on anatomy, a number of other Da Vinci scholars have either implied or outright stated that Da Vinci saw the human body as a machine, and that does sort of fit within the idea of systemic thinking. But you disagree?
No, I disagree very strongly. And this is something that is very difficult to understand for people, because everybody knows that Leonardo was a mechanical genius and invented numerous machines and mechanical devices, but his worldview was not mechanistic. He didn't see the world as a machine. He recognized that the animal body, including the human body, needs mechanical devices to move. And so he studied mechanics mainly for that purpose. But the origin of the movement, he says, lies in the soul. And today we would translate this into lies in consciousness, or lies in cognition, as we say today. And so there are numerous passages where it is clear that he does not see the body as a whole, as a machine.
You're tuned into Science for the People, and I'm talking to Fritjof Capra, the author of Learning from Leonardo. You covered so many concepts and inventions in your book. Is there anything that we haven't talked about yet that is sort of one of your favorites?
Yes, and that is ecology, and that was a big surprise to me, that, I had an intuition when I saw exhibitions of Leonardo's drawings in the 1990s in various museums. I had an intuition that his science should be interpreted from a systemic point of view, as a science of patterns, of relationships, of transformations, and that was confirmed by my research. What I didn't realize was, first, that his central theme was the nature of life, and secondly, that he had an ecological approach to understanding life. I already mentioned his understanding of water as the nutrient and matrix of life. He also observed the cycles of growth and decay in nature, and that was one of his main arguments for the earth being alive, which, by the way, was common understanding at the time in the Renaissance. The idea of Gaia, the living earth, was commonly held. But Leonardo argued scientifically that wherever we look on Earth, we see growth and decay and cycles of change. And that's one of the characteristics of life. He also talked about food chains, how food moves, how bodies move through other bodies when they're eaten by other bodies. And he intuited the modern concept of food chains. And also in his technology, I would say that Leonardo was the first eco-designer. He took nature as his model. That's particularly strong in his design of flying machines, but also in all his other designs. Nature was always the model, and he had a tremendous reverence for nature and tremendous respect of nature. So in that, being an ecologist and eco-designer, I think that's an important part that I also discovered, and that is important to mention. And this is important because Leonardo's work is not just fascinating intellectually, but also very important for our time. Because today we can see that our sciences and technologies have become increasingly narrow in their focus and don't really understand our multifaceted problems from an interdisciplinary perspective. And so we urgently need a science and technology that honor and respect the unity of all life, that recognize the fundamental interdependence of all natural phenomena, and that reconnect us with the living earth. And that, of course, is exactly the kind of science and technology Leonardo outlined and practiced 500 years ago. That's why he's so important for our time, and this is why I called the book Learning from Leonardo.
So you mentioned some things that I would consider lessons. So how could we actually apply those lessons then, practically?
Well, we have to broaden our focus. We cannot learn anything in terms of his discoveries, so in terms of his method. All this has been rediscovered. But we can be inspired by Leonardo da Vinci, by his respect of nature, by his attempts always to collaborate with nature rather than dominate nature. And that's very important for our time. And by the systemic approach, which is practiced today, but not in mainstream science. You see, the systems view of life is still a minority. I would say it's the avant-garde in science, but it's not the dominant view. And that's a very important thing to learn from Leonardo.
Fritjof, thank you very much for being here. Wonderful book.
You're very welcome. The pleasure to talk to you.
And you can find a link to Fritjof Capra and Learning from Leonardo on our website at scienceforthepeople.ca.
Science for the People is a weekly radio show exploring everyday life from a scientific perspective. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to connect with us on Facebook, Twitter, and Google+, or to subscribe to the podcast in iTunes. And now, back to the show.
Welcome back to Science for the People. I'm Desiree Schell, and I'm here with Scott Barry Kaufman, a cognitive psychologist who investigates the development of intelligence and creativity. He writes at the Beautiful Minds blog on scientificamerican.com, and he's the author of Ungifted, Intelligence Redefined. Welcome, Scott.
Hi, great to be here.
So maybe start out by giving us some background as to how and why we started measuring intelligence in the first place.
You know, the original purpose was never to measure intelligence per se. A Frenchman by the name of Alfred Fresne was given the task of trying to develop a test that would best identify those who are profiting from mainstream education and those who needed alternative education. He never really conceptualized it as a test of really intelligence, but just as just a test trying to serve that one purpose. When the Americans, when it crossed overseas to North America, people were much more excited by its potential use in my country to measure intelligence, because people are very excited by its, the fast food sort of culture we have here, the efficiency that you could photocopy thousands and thousands of test banks and then just do mass testing. And in a lot of ways, that was kind of the roots of the whole standardized testing movement as well. It's still very, very popular today.
What does an IQ test measure exactly? Because intelligence means a number of different things to different people.
A modern IQ test, if administered by a competent test administrator who is very well versed with like the latest theories and the latest test batteries, can glean some valuable information. They're not useless tests. They can be used sensibly as a tool to measure about 9 intellectual functions, main intellectual functions, things such as mathematical reasoning, what's called fluid reasoning, which is your ability for on-the-spot novel problem solving to like figure out abstract problems on the spot, and working memory, holding things in your head, lots of things simultaneously in your head and manipulating them, visual spatial reasoning, reading comprehension. And you could see how this assortment of intellectual functions that I just described are relevant to educational success. So they're not completely useless or irrelevant. They can be a tool to help you assess a student's needs in an educational context. The problem really is, for me, the problem is when we do more than that with those tests.
Oh, we're going to go there. So I understand that there isn't just one IQ test, correct? There's a number of different ones.
There are not that many that are very well validated. I'd say the Stanford Binet and the Wechsler test, or the WISC, are the most popular. Also, the Woodcock-Johnson, it's called the Woodcock-Johnson test. I think they just released the fourth edition. So these maybe 3 or 4 main test batteries. But the thing that a school psychologist can do is they can apply what's called the cross-battery approach, where they take each student. And again, this is what a really competent educational psychologist would do, is look at the child in front of them and treat it as a problem solving process. What are the needs of this child, and to help determine that, they could use this cross battery approach where they mix and match different subtests from different batteries to kind of come up with a customized battery for that student. Unfortunately, I think the minority of school psychologists really use that approach.
Well, so what do the scores mean?
So you have a what's called a global IQ score, and that's like your total IQ score.
Right.
And that's what we hear about in popular discourse, right? We say, what's your IQ? What's your IQ? Everyone's obsessed with IQ. Look, it's just a summary score of, let's say, you go and you do the physical fitness test, right, in gym class. So they make you, do the chin pull up. They make you run 500 meters dash or whatever, I guess 500 meters wouldn't be a dash, but they make you do all these. Did you have to do the physical fitness stuff in high school? Do you know what I'm talking about?
Yes, I know.
So
I have painful memories. Yes.
They make you do all of that, and then you could just average all the performance across 9 different of those kinds of physical fitness tests to come up with a global physical fitness. So it would give you a rough and ready idea of what is your physical fitness. That's the logic behind a IQ score, is that it's just a global summary of where you're at in terms of your global intellectual capacity. But the global IQ score, in reality, is de-emphasized by modern contemporary IQ tests. So in the IQ test manuals that are used today, and again, competent school psychologists are very well aware of this. I'm not saying anything new to those listeners who are trained, as school psychologists. To look at the patterns of cognitive strengths and weaknesses is much more important and useful for developing interventions. But there's still so much remnants in our society of that global IQ score, and using that to sort kids as either globally gifted or globally ungifted, as though there's some sort of dichotomous, as though that actually exists, a dichotomous world where either you're a gifted human being or you're an ungifted human being. And I spent most of my childhood being treated as though I was an ungifted human being. And a lot of what I talk about is my personal experience in special education, and trying to talk about the latest research, how we can better use research so kids stop falling between the cracks, because I think a lot of kids really are falling between the cracks because of a really outdated notion of the malleability of intelligence.
You mentioned a lot of qualifiers there, which I like, but unfortunately IQ scores have been linked to everything from morbidity to mortality. So what's the connection?
That's absolutely correct. I mean, if you want to really know precisely what a global IQ score is tapping into in the brain or in terms of cognition, we've actually come to a pretty good understanding of that. It's a pretty good measure of what's called executive functioning. So your ability to plan, reason abstractly, problem solve, your ability to control your attention, your ability for mental flexibility to change your focus of attention when you want to, and things like mindfulness meditation and physical exercise and CogMed and their programs that try to increase some of these intellectual functions. So it's not unimportant, and you do find that this global IQ score, because it does measure planning and reasoning and comprehension, it does relate to your ability to follow instructions on medical things. It does affect your personal life. It's not wholly impractical, these skills. I think what is really important to recognize, and something that is really my mission, is not so much to redefine intelligence and completely distort the whole meaning of intelligence, but even taking what we think of as intelligence intuitively, the ability to learn, problem solve, reason. I think that what we need to do is recognize that even defined in that traditional way, there are so many ways for people to express into their intelligence, their unique brand of intelligence, and those skills can be developed. And they can be developed in a very practical, meaningful way, even if their IQ score never budges. This is a paradox that I have been trying trying to solve in my career and try to show people that let's not get so tripped up on there being one authentic, truthful intelligence like the IQ score and everything else being irrelevant. I think there are so many indicators of intelligence all around us. We're just blind to them because we're not looking for them.
But unfortunately, IQ is used as a predictor of things like educational achievement, of special needs, of job performance, of income. So are those predictions accurate without all the other stuff that you're talking about?
Now, there's one sense we can talk about accuracy. We can talk about group correlations. We can talk about what are the overall probabilities statistics show, and then if you have your own IQ result, you can try to compare. It's like saying you want to play the lottery, right? You'd rather invest in a lottery where your odds are 1 in 100 than 1 in 5 billion, right? So statistically speaking, your IQ score relates to the probability of certain successes in life. But I think that is extremely, extremely dangerous for you as an individual to get too tripped up on ultimate level of success based on your IQ score. According to my IQ score, I wasn't likely to graduate high school, and I somehow managed to get a PhD in cognitive psychology. Did I fool the system? Am I not really authentically smart, and I've just fooled myself and everyone by doing exactly the motions of what it is to be smart, yet I'm not really smart? What the hell does that even mean? These are questions I've wondered my whole life. I think that we get too tripped up on the linguistics and the words we use and using these tests to limit. I think we should stop using these tests as limiters. I think we should only use them for the purpose of what Alan Kaufman, who's one of my heroes, calls intelligent testing, not intelligence testing. We can use tests intelligently to problem solve needs, but I think that we need to, and this is a bold claim, but I do think we need to stop intelligence testing. We could start with learning disabilities. Within the learning disabilities literature, there's a whole faction of people who think that we should just burn the IQ. Now, we don't need to use IQ tests, that they're irrelevant, that what we should do is actually look in the classroom and just focus on academic achievement, focus on a child's learning needs in that moment in the educational context. These people who are anti-IQ tests in the learning disabilities program they see those tests as irrelevant to whether or not a child should get special education resources. And they have a lot of good points in their argument because there's a category of called a slow learner. And if your IQ is between, I think, 70 or 80, you're a slow learner. What that means is that you're not low enough IQ where you qualify for mental disability, but your IQ is not high enough for them to think that you're actually capable of remediation. Right. So those kids, we just give up on the slow learners. We say you're not smart enough to even learn how to overcome your disabilities. And I think that's obnoxious, for one. I think it's discriminatory. It's what I've called testism, which I'm trying to coin that term. Maybe it'll catch on finally in this radio interview. But testism, I think, is just as bad as racism. It's as opposed to looking at the color of someone's skin and trying to predict their future, you predict someone's future based on the outcome of one testing session. And I think that's a form of discrimination that we've never really come to terms with in our society. And I think that that's not a good way. Using global IQ scores to assess whether or not someone is capable of even remediation we shouldn't use it for that purpose. But there is another side of the debate, and that's the IQ test makers who argue, well, hold up, our tests, let's not throw the baby out with the bathwater. Right. These specific subtest scores in these IQ tests do correlate with specific class subject performance. For instance, visual spatial processing might correlate with math performance, or quantitative reasoning, fluid reasoning might correlate with math. So they say it does add additional information. And I think they have some points too. I think we can integrate the two approaches and have a model in school where we just simply don't use these tests to limit, but we just use them all as data gathering, data gathering process, gather as much data as possible. All the way on the giftedness end of things, on the opposite end, everyone rips their heads off over issues such as, is giftedness who you are, or is giftedness what you do? Mm-hmm. Right? So the whole faction of parents, educators that say you're born gifted and you're gifted the rest of your life, and that's it. They don't want these parents. Think of it from a parent perspective. You don't want to have to retest your child every year if they qualify for gifted at age 2, right? They don't want their child to ever lose the label, right? But there's another side of that coin. That means that if there isn't retesting, then if you were measured as ungifted at age 2, there's assumption that you'll never be gifted, right? So that doesn't seem entirely fair either, does it?
So can IQ change throughout your life then?
Oh, absolutely. Oh my God. There's been studies showing that longitudinal, following kids up from the age of like 4 to 17, finding that only 40% who meet a certain IQ threshold for gifted programs by one age meet it later. And and there's huge variability. Lots of people that didn't make that later. So if your qualification for gifted programs relies on an arbitrary IQ threshold, 130 or above and you're gifted, 130 and below and you're ungifted, then that's very arbitrary, right? There's such error variance, or people are going to fluctuate. Kevin McGrew, who is a researcher, found that your IQ score can be expected to fluctuate something around 12 IQ points from one testing session, one test battery to another test battery.
And that's actually substantial, is it not?
It is. Imagine it with these arbitrary cutoffs. What if your IQ is 128 on a certain day? There's a really good chance you could get to 132. Why not? There's no. Let's not get too tripped up on these arbitrary distinctions that we have to remember. We as educators are the ones that came up with them for no darn good reason. I'd say the most sensible thing in terms of equity and fairness for everyone is getting rid of these stupid labels. And just look at every child at any moment in time and assess their readiness for engagement. Nothing more, nothing less. I've argued we need to reconceptualize potential, not in anything. It's not something you're born with. It's like marked on your forehead. You either have this potential or you don't. But potential is a moving target based on your engagement in something that's personally meaningful to you. And at any moment in time, someone may be ready to engage in more accelerated resources, or they may be ready for remediation. Whatever their readiness for engagement is, we give them those resources. I think it is morally. I feel very strongly about this. I think it is morally bad. It is immoral to do that. Yeah.
Well, let's just tear this down some more, because I've often heard that IQ testing is culturally biased as well.
That's another can of worms that's really tricky. The word bias has a very specific definition in the psychometric statistical literature. I mean, it has a technical scientific definition, which you can actually measure to see whether or not a test is biased, and that is, are people achieving more than that test is supposed to predict, by some other marker. The problem is we don't know what other indicators of intelligence there are. So, for instance, if someone is performing very high on things that we would consider to be measures of intelligence as well, and their IQ score is consistently under predicting that, we say that IQ test is culturally biased against those people. I'm just telling you the statistical definition of that. But you can see logically how tricky that is. What are we comparing IQ to? What else out there are we calling intelligence?
Well, I guess that's my question. So if not IQ, IQ testing, then what? Are there other ways that we can go about solving the same problem, finding the same information?
I think so. I think if we get rid of this notion that there's only one true intelligence and everything else revolves around it, this is a great paradox, which I often get in arguments with my hardcore IQ colleagues about. Let's say your IQ is 100, and you win the Nobel Prize in physics. To the hardcore IQ researchers, they conceptualize that situation, the reality that being, oh, look at that. Look, that person was able to get the Nobel Prize despite average intelligence. That is a paradox I think is bullshit. The paradox isn't the statement. That statement. Right. I say no. You're so tied to you don't see the truth. You don't see the wide world out there, which is that people bring and mix and match so many of their unique personal characteristics in really creative, unique ways to express their unique intelligence to reach the same outcome. They don't see that. They don't have that. They're lacking in the fundamental creativity to see that. But I think that's actually the truth of the world, is that there are many paths to greatness. There are many paths to the same success, and every person who reaches the same point is equally worthy of that label intelligent.
Well, you actually wrote an article just recently for the Beautiful Minds blog about creativity and child prodigies. And I remember you pointed out that there was quite the span between the results of the children's IQ tests.
Yeah, prodigies are very interesting. I'm very interested in savants, prodigies, every part of that spectrum of ability, and looking to see how it develops. And you find that, I mean, all talents are developed. I do think there is such a thing as talent, by the way. I've done some work with Angela Duckworth, who's done a lot of work on grit. We arguing that expertise is talent times effort. Both are important. But talent, really just as I define it in my book on Gifted, is simply a proclivity and passion to master the rules of a domain. It's not, and that's all the fundamental seed is of talent, at which it accelerates your learning curve. So people who have a proclivity and passion for something, they learn much, much faster and more rapidly in something. But that can happen. You can discover that or get into contact with that talent at any point in your life. And when you do, you'll see a huge acceleration in what you're trying to learn. And I think that we underestimate a lot of factors that can set off that talent, things like inspiration. Like, oh my God, I'm suddenly inspired to master the rules of this domain, and boom, that sets off the learning curve. Passion. We underestimate the extent to which a lot of these things can unleash that talent. What you see in prodigies is a perfect, what David Henry Feldman calls coincidence, a coincidence of factors such as high passion, motivation, inclinations from an early age, support, usually parents who give them all the resources they need. By the way, most of these kids are white. I mean, higher SES, like I think
higher
that
socioeconomic status potentially.
absolutely.
Right.
I think we shouldn't ignore that the truth of all these things is that these kids, there is a talent component there, but there's a great combination of factors that affords them that great opportunity. What breaks my heart is seeing so many kids, ethnic minorities, kids in low socioeconomic status, poor schools, who could absolutely, given the resources, demonstrate just as much possibilities. And that's what breaks my heart.
Well, that's why I'm so interested in this topic, because it is not an abstract argument, because IQ is used in public policy decisions and in employment situations and assessing how someone can access social services. Ultimately, then, what can IQ tell us that is practical, that is helpful?
Well, what I was saying earlier is that if you use an intelligent testing approach, so you're a school psychologist and the parent goes to the school psychologist for a reason. There's a need to be addressed. No, a parent doesn't take their child to see a school psychologist and say, I want my child's doing absolutely fine in school. There's no problems at all. Just test his IQ. No, I hope that doesn't happen. So they go there for a specific need. And then it's the school psychologist's responsibility to really problem solve and figure out what is going on there. So you can use an IQ test battery sensibly to identify a pattern of cognitive strengths and weaknesses. That can absolutely be useful information. But I'm not convinced, and this is really where this is something I really strongly believe. I'm not convinced that the first reason for a child who's low performing in school is low intelligence. The view that I've become to really believe, based on over 10 years of research, is the amazing importance of engagement. Engagement, as I define it, which is a personal, deep, meaningful, personal, long-term connection to the learning material. In my opinion, we've overlooked that as the first reason for low achievement, not low intelligence. So we've, over 100 years, our first default go-to reason, cause, is low intelligence or low IQ. And I think that we've been ignoring the big elephant in the room, which is the engagement elephant.
Scott, everything that you've said is going to be horribly controversial, and I'm sure I'm sure the conversation will continue on our website. Thank you so much for being here.
I hope some people agree. Thank you.
And we've linked to Scott Barry Kaufman, author of Ungifted: Intelligence Redefined, on our site at scienceforthepeople.ca.
On the next episode of Science for the People, we're learning about the science and math on the cutting edge of computing research. We'll talk to electrical engineering and computer science professor Scott Aronson about the hype and the hope for the field of quantum computing. And we'll discuss one of the most intriguing open problems in mathematics with Lance Fortnow, chair of the School of Computer Science at Georgia Tech and author of The Golden Ticket, PNP and the Search for the Impossible. That's next week on Science for the People on your local radio station or online at scienceforthepeople.ca.
This is Science for the People. I'm Desiree Schell. And it looks like we're heading into conference season, so I'm back with an event that I think might interest you. I'm joined by Chelsea Dufresne and Andrew Tripp from Skeptech. Welcome to both of you.
Thank you for having us.
Great to be here.
Now, tell us a bit about the conference.
Skeptech is a conference that sort of sits on the intersection between science, innovation, and skepticism. So it's more than just another science conference. It's one that tries to put science in context with society. Putting it in context means that when you produce a study, rather than just looking at the study itself, you also need to look at where the study is coming from, what basic assumptions they're making that are based on cultural assumptions versus just a standard scientific assumption.
Perfect. So it's actually digging a bit deeper than maybe other conferences might do.
Exactly. It's science and society.
So now what's the theme of the conference?
At Skeptech this year, we don't have specific themes each year, but this year there are a couple of specific tracks of talks that are unique this year. So we have 3 of them. One of them is, the social process of science. Talks that would fall under this category include, what do you have to deal with being, say, a woman in the sciences? What assumptions about you, what assumptions about how you're supposed to conduct your own career that other people are making about you based on your gender? Stuff like that. Then we have a modern science and tech track, a little bit more updated science, stuff that's not just about the social impact, but about the research itself. And then we have basically a series of tool talks. So if you're a scientist or an activist or both, here are the best programs for you to use. Here's how you secure all of your content online. Here's how you deal with like a DDoS attack. Here's how you conduct your manner online so that you can be taken as a professional. Or here's how to start blogging. All of those little details that you need to master in order to spread your message. That's basically what that is about.
So that's really everything from the esoteric to the very, very practical. So, and this is a student-run conference, correct?
Yep, we are all either undergraduates or like those of us who are in their weird summers right before graduate school. And we try to include a lot of students within the conference itself, not just internally, but on panels and things right alongside with our major headliners.
Now, why would you spend your spare time doing this? Because I remember school and I didn't have a lot of time.
None of us sleep, and we all get bored, and really this just kind of created itself. Actually, no, we do try to sleep. So all of the organizers have a unique reason for being involved, obviously. It began out of basically us wanting to participate in science activism and also not having enough time or relevant enough opinion to blog all of the time. And so we're like, well, we can put a bunch of relevant voices in a room and we can get stuff done in the span of a weekend and really change people's ideas.
Now, Andrew, are all of you, do you have science backgrounds or is it more of a variety?
No, I think it's a solid variety. For instance, I've taken on a bit more responsibility recently, but Chelsea brought me in as an organizer. I was just an attendee and a panelist last year, but Chelsea brought me in this year specifically to work on the safe space policy, part of the committee who wrote that. So basically, some of your listeners may know, over the past few years, particularly in the skeptic and atheist and scientific communities, there's been a big controversy about making conferences safe spaces. So there are dozens and dozens of documented accounts of particularly women speakers being sexually harassed, touched without consent, and etc. And have always wanted to be the kind of conference that does not tolerate that kind of thing. So what our safe space policy does is sets out for everyone the ground rules, in that we want to make it very, very clear that we do not tolerate any kind of personal interaction that is not consensual. It's our duty as organizers to make sure that everyone who attends Skeptech is as comfortable and as safe as possible. And so that's what this policy is set out to do.
Oh, I love that. Now, I should ask, now, is this a conference for students only, or if you are not in school, are you allowed to go?
Oh,
No. Everyone is welcome, and there's no attendance fee. It's a free conference.
I hope everyone heard that part. It's a free conference. And where is this free conference?
This is in Minneapolis, Minnesota, on the campus, the University of Minnesota campus.
And what's the date?
The date is April 4th through the 6th. It's the first weekend in April every year.
I am so jealous. This sounds brilliant. And if people are actually in Minneapolis or would like to take a road trip, where can they find out more info?
They could reach us at skep-tech.com.
Chelsea, Andrew, thanks very much for stopping by, and sounds like a great event.
Thank you.
Thank you for having us.
And of course, we've linked to Skeptech on our website at scienceforthepeople.ca. You'll notice that we've also linked to the show Twitter feed, Facebook page, Google Plus account, and to iTunes so that you can listen to past episodes, subscribe to the show, or leave a kind and generous review. Thanks for listening, and we'll see you next week on Science for the People. Science for the People is recorded in Edmonton, Alberta. The show is produced by Rochelle Saunders. Ryan Bromsgrove is our promotions manager. Our social media manager is Chelsea Butler. K.O. Myers updates our website. Helen Quivalon is our publishing liaison. Ed Haynes is our guest coordinator. We get research help from Josh Whitten. The show is edited by K.O. Myers and Ryan Bromsgrove. Our theme song was written and recorded by Fractal Pattern, and its title is Binary Consequence. The show is hosted by Rochelle Saunders, Marie Claire Shanahan, and me, Desiree Schell.